Hello, this is Mr. Gilmore with the 1.2 Segments and Rays lesson. In the 1.1 lesson, we saw two figures known as points and lines. Now, today what we're going to do is take those points and lines and from them create two new figures in which, here's our title, segments and rays. Let's start with what segments are. We start with what a line segment is, or really we can just call it a segment. A line segment is 2 points on a line and all the points between them. So let's say we're given a line. We can actually create a line segment from that given line. We will choose then 2 points, really anywhere on that line, and we select all the points between them. What we do then is we really truncate our lines at the 2 points that we've chosen. We're going to give a special name to those 2 points. We're going to call those 2 points endpoints. Pay close attention to where those two endpoints are and how we what names we give to those 2 points, because whatever names that those 2 points have will be used to help us actually to name a line segment. So when we name a line segment, we choose the letters that have been given to the end points. So for example, in the figure below, we have a line segment. This line segment, the two end points are point A and point B. So we're going to call this line segment AB, or just simply segment AB. Symbolically, we can actually add something above the two letters so that we don't have to write the word segment or line segment out. We can write a bar over top of it. Now, yesterday we saw how we named a line. So when we named a line, we put over top of it a bar with two arrows. But when we're naming a line segment, we can then drop off the two arrows and simply just put the bar over top. So here we have a line, and here we have a segment or a portion of that line. Now, the order in which we choose our endpoints and how we name them, that's irrelevant. I could actually call this line segment AB or line segment BA. So with lines and line segments, order really doesn't matter in how we name the line. But we're going to be really cautious when we get to rays and how we name rays, because we're going to see that order isn't always irrelevant. Let's take a look at what a ray is. A ray is another figure that we can create using a point and a line. In this case, let's say we're given a line. In this case, we only choose a single point on that line, and then we choose all the points on that line which lie on one side of that point. Essentially, what we're choosing is we're choosing a point and then a direction to go in. Now, when we look at our diagram below, you'll notice that we have this dashed line still. There's that dashed part which represents the line that exists there. So we do have this line M, and we've chosen a point on that line. The point that we've actually chosen is point A. And point A, again, we're going to give a name to. We're going to call it the end point. Now, we have a choice then. Once we've chosen our point, we have a choice in which direction we're going to choose. Because that line, we can choose either side of that point. Well, whichever side we choose, we're choosing all the points along that side. Now, you'll also notice that in our diagram below, we have a second point labeled point B. That's going to be important in how to name a ray. We'll see that in just a moment. That point B will be there to help us name the ray. Point A, however, is part of the definition of our ray. It's that end point, right? That point that's on a line. And then we choose all the points on one side of that line. Now, to name a ray, you have to be very careful. Order does matter when naming rays, but it actually is quite simple to name a ray, because really to name a ray, you have a process. It's a very simple process. You start by picking the end point. That is the very first letter you will choose, or you will write down when you name any of the rays in this diagram, or in the future for a homework assignment or on a test. You start by picking the end point. Then what you do is you pick a letter or pick a point that is in the direction that the ray is going. So for example, in our figure below, there are actually two valid ways we can name this ray. We start by picking the endpoints. We start here at point A, and then we're going to choose a second point that's in the direction the ray is pointing. So we can choose either point B or point C. So we have two valid names. I have ray AB or ray AC. Both of those names describe the same figure. So order does matter. I can't put B or C in front because uh, I'm starting where my endpoint A is and going in the direction of my ray. You'll also notice the symbol over top of the ray name. You'll notice that in comparison to what we've seen with lines and line segments, that there's only one arrow this time. And when we look at the symbol, it really does kind of give us a picture of which direction the ray is going in. If I would just had the name of the ray, I would be able to tell just from the name that the endpoint is at point A and it's going in a direction toward point B. And so from that, I could actually generate a diagram or draw a new figure of a ray where the endpoint is A and a point along the ray is point B. So be very careful in how you're naming rays. With lines and line segments, there's some freedom there. There's not so much freedom with naming a ray. Because be careful, if I were to actually name, if we were looking at a name here, ray, let's say BA, well, that actually means that I'm starting at point B and heading toward point A. That's not the same ray that's described here in the figure. So we've got to be extra careful with naming rays. Now, this is going to be a pretty bold statement that I'm going to make, and I'm going to back this statement up later in another lesson in this chapter. So when we talk about a line segment, remember a line segment, is 2 points on a line and all the points between them. When we give that line segment a name, right, we can either just say line segment followed by the two letters of the endpoints. So in this case, it would be line segment AB, or I can place a little bar over top of it. But here's the bold statement I'm going to make. Every line segment has a measure. Every line segment has a measure. What I'm really saying is that I can determine a length for every single line segment. That's a pretty bold statement that I'm making there. I will be able to back that statement up in another lesson this chapter. But there is something we have to then represent the length of a segment and distinguish it between the name of the segment. So when we name the segment, that's where we find the little bar over top of our two endpoint names. However, when we want to talk about the length or the measure of a segment, there's a really simple way of talking about the measure of a segment, and the simple way is just taking that bar off. So you'll see in our example below, segment AB, the name of segment AB has the bar over top of it. But the length of segment AB, I've dropped that bar off, and what I simply have is this AB. Now, there's a second way I could have said that, and that's by keeping the bar on top of the segment AB and placing this little M in front of it. That little M stands for measure of. So both of these statements say the same thing. This statement here, AB, and this statement here, M with the bar over top AB, they both read the same way. They both say the measure of or the length of AB. Now, I want to challenge you here to think about this. So we can say that line segment AB is really the same as line segment BA, right? Those are the same things. So that's pretty easy, right? I have some freedom in naming my my figure here, naming my line segment. But here's a second question: is line segment AB the same as AB, the length of AB? That is the correct answer there is no. Those are not the same thing. See, what I'm comparing there in the second statement is I'm comparing the actual figure or the name of the figure to the measure. I'm comparing an actual object to a number, and I can't do that. You can't compare an actual object to a number. You can compare numbers to numbers and objects to objects, but you can't compare an object to a number. So be very careful. That's why we're learning these symbols that we place over top of our either segments or rays or lines, and we want to distinguish that between the measure or the quantity that this value holds. So just be very careful. You'll see a section like that on the worksheet where we talk about comparing the segment name to the segment measure. They're not the same thing. Okay, they're not the same thing. Hash marks. Let's talk about hash marks. We are going to see diagrams and a lot of diagrams throughout the course of geometry. Now, let's say I want the reader to know something. There are different ways symbolically that I can tell the reader something from the diagram. So let's say I want to tell the reader that I have two segments that have the same measure, meaning they are the same length. How could I then denote that on a diagram? Our method that for this year, we're going to be using hash marks to denote equality. So if we look at our example below, we're given two segments, segment AB and segment CD. Now, let's say I want the reader to know that AB and CD are equal in length. I have put a hash mark on each of these to say that those two segments are equal in length. Now, we have to be very careful with hash marks. Hash marks really only say one thing. The only thing they say is that these segments are equal in length. And we have to be very cautious with our hash marks. We'll talk a little bit about that here in the next couple of slides. So if I was to let's say, put a second pair of hash mark or second pair of segments here, and I want the reader to know that those two segments are equal, I could put hash marks on them. But I've got to be very careful then with hash marks, because let's say I have multiple pairs of equal segments. How would I denote that to the reader? Well, we use then multiple hash marks on each segment. So an example here below, we have three pairs of equal segments. AB is equal to AG, AC is equal to AF, and AD is equal to AE. Well, if I want the reader to know that I have three pairs of equal segments, I can use single hash marks then for one pair. I use a double hash mark for the second equal pair, and then a triple hash mark for the third equal pair. So I've got here the single hash mark AB equals AG, right? You see the double for AC and AF, and then there's the triple AD for AE. And of course, it didn't have to go in that order. I could put the triple hash mark really on the first pair and the double on the last pair. I can move, really, I could interchange where my hash marks go. But really what this tells my reader is that I know, right? I'm telling my reader that I know that I have some equal segments here in length. Now, I'm going to again challenge you here, okay? And we're going to talk about this in the last couple of slides. I'm going to challenge you with this question. So we're given that AB is equal to AG. That's definitely true. Check. But here's a question for you. Let's take a look at AB again. The question is AB is marked with one hash mark. AD, let's take a look at AD with this segment here, AD, right? It's marked with a triple hash mark. My question to you is AB equal to AD? Now, a lot of you may say no. And if you say no, then you're wrong. So then you go, oh, so if it's not no, it must be yes. Well, if you say yes, you're also wrong. See, hash marks, remember, only say one thing. Hash marks only say that segments are equal. They do not say that segments are not equal. They only can say equal. They cannot say not equal. So if you see a single hash mark and a triple hash mark, you can't jump to the conclusion by saying that they're not equal. But the thing is, you can't also jump to the conclusion to say that they are equal. So how do we tackle this? Right? You said that if the answer was no, then that was wrong. That right? But you also said if the answer was yes, that's also wrong. So what do I say to that? How do I answer a question where I say AB is equal to AD? Or I'm asking that, is AB equal to AD? You simply will say cannot be determined. And we'll talk about this on the worksheet. It's called CBD. Cannot be determined, right? We just don't know. Now, here's another thing. you may be looking at AB and AD, and this is where we gotta have to break that mold. You're thinking, wait a minute, AB appears to be longer than AD. It looks like it's longer. We have to avoid using that looks like justification in the future. We can't say things are true based on what they look like because our eyes can be deceived by what things look like, and we can't base things off of what our eyes perceive. It has to be on what the truth holds. So be very careful in some of these answering questions. Let's actually dive a little deeper into that. This cannot be determined. Let's take a look at this diagram here. Okay. There are a lot of assumptions that we simply cannot make. From the diagram, I can tell you one absolutely true thing from that diagram. The absolutely true thing that I know is that AD is equal to BC. And that is absolutely true. Why? Because it's been marked with these hashes. So AD is definitely equal to BC. But your eyes are deceiving you. It really looks like you're looking at a square, but do you know it's a square? Are you absolutely positive it's a square? Well, if your justification is yes, because it looks like that, you have to stop saying that. You cannot say things are equal because they look like they're equal. So the thing is, we honestly do not know that length AD is equal to length AB, or even saying that AB is equal to CD, right? These other opposite pair of sides. We can't say that. So the only thing we're absolutely certain of in this diagram is what is given with the markings. AD is equal to BC. So just be very careful with jumping to conclusions. All right, we'll talk more about jumping to conclusions or making the wrong assumptions in many different lessons. To finish off today's lesson, we're going to look at one last definition called midpoint. So if let's say we're given a segment, if we have a point in on that segment such that it cuts this segment into two equal subsegments, then we can call that point the midpoint. So here's an example. So if point C lies on segment AB and AC is equal to BC, then we can say that C is the midpoint of that segment. And it's very appropriate then for us to use our hash marks to denote that C is a midpoint. As you take a look, I marked AC and BC with those single hash marks. That means the length of AC and the length of BC are equal in measure. So if I'm traveling from point A to point B, I know that the exact halfway mark is at point C because I've traveled halfway the length of the entire segment AB. You'll see you'll work with some midpoints on the worksheet, the 1.2 worksheet. So that is the end of our lesson. We encountered actually a couple definitions today: definition of a segment, definition of array, definition of midpoint. We also talked a little bit about hash marks, and we saw that there are some dangerous assumptions we can make. Please do not fall into those traps. They're easy to fall into, and that's why we're going to be working with avoiding this phrase looks like. If you do have any questions on this lesson or the worksheet, please make sure to send me an email or get a hold of me somehow. And with that, be good and do good.